Welcome to the Crazy Hat Chemist. So here we are doing another video in atomic structure and electron configuration. So let's get moving. Bam! So today we're talking about the atomic line spectrum for hydrogen. I showed you in diagrammatically what that looks like and those associated wavelengths looking at the atom. So I want to show you what that looks like in another fashion, not with the atom, but what it looks like experimentally. Okay, so I'm going to label all these parts here for you. This is a hydrogen gas in a spectrum tube, and there's a high voltage that is going to be applied with this. Now, it's a population of hydrogen atoms, so some of those hydrogen atoms are going to have high energy, and some of them have low energy, meaning that if they are excited with high energy, then those electrons are going to be very far from the nucleus, like n equals 6. If they have absorbed a low amount of energy, then they will have like n equals 3. When each of those drop and fall, then they will fall to n equals 2, and then we will see them in the visible region. Are there electrons with higher energies beyond n equals 6? Absolutely. Are there some that fall to n equals 1 or a different value, n equals 3? Yes, there are, but we cannot see those with the visible eye because we are looking just at the visible region. All right, so we got a population of hydrogen gas, hydrogen molecules inside that spectrum tube. We're going to apply a tremendous amount of voltage to that. We're going to pass that light through a slit. That way we focus the light, and we can focus that light through this prism. This prism is going to separate the light in terms of its wavelengths. And I'm hoping that you have seen this before, maybe on the cover of a famous Pink Floyd album cover, or maybe hanging from your rearview mirror in your car is a prism, and it's separating it out into the whole visible region, and that is like a rainbow that you should see. So then we're going to detect it with a detection screen, and you can see this with like a spectroscope or something like that. Okay, all right, so there is the light that's emanating from the hydrogen atoms. Okay, and it's going to pass through this prism. As it passes through the prism, that wavelength, all the wavelengths of light are going to be separated because it will go through different lengths in the prism itself. Okay, so now it's being separated, and you should see those 4 visible lines. That's the atomic line spectrum for hydrogen. And we calculated one of these, and that was that green line already. That's the 486 nanometers. On the very bottom, you should see the red line at 656 nanometers, the blue line, slightly violet, at 433.9 nanometers, and the violet line at 410 nanometers. Now, if you recall from the previous video, that is the red light has long wavelength, low energy, low frequency, and the violet region has short wavelength, high energy, and high frequency. Okay, there is no other element that has these 4 lines in the visible region as a sum total. That makes it a unique atomic line spectrum only for hydrogen. This is why we know that the sun is composed mainly of hydrogen gas, because when looking at the sun through a prism, through actually a spectroscope, which you are not to do because that is very dangerous for your eyes, but with a machine you can do this. When you separate out the visible region, you can see that the sun is composed of hydrogen. This is why we know, even without visiting the sun, what elements the sun is composed of. We can look at other stars and figure out what stars are composed of as well, because we can see the light coming from those stars. And each element on the periodic table has its own unique atomic line spectrum, just like you have your own unique thumbprint, fingerprint, etc. Hopefully that makes sense for you. All right, so that is another cool video in chemistry. Here's another crazy hat. I hope you have a fantastic day. If you like that video, give me a thumbs up. If you like the hat, give me a thumbs up. If you like my videos, subscribe to my YouTube channel. I greatly appreciate that. Look for more cool chemistry videos next time, and I'll see you then. Bye now.